Now, when I sketched this graph, I said it would be possible to locate these turning points, these stationary points, but I didn't actually do it. Let me show you again how, just to remind you. We have to get this original function and differentiate it, then set the derivative equal to 0. So, y equals x squared plus 3x over x minus 1. All right, this is a quotient, u over v. And again, I'm going to use the quotient rule, not the product rule, because it just makes the algebra much simpler. Meant to be u is the top, x squared plus 3x. And v is the bottom, x minus 1. So u dashed is 2x plus 3, and v dashed is 1. Okay, if y is a product of u on v, then y dashed, the quotient rule, says y dashed is v, u dashed minus u, v dashed over v squared. Put in what we know. V, x minus 1, u dashed, 2x plus 3, minus u, x squared plus 3x, v dashed is 1. Well, that was easy. Over v squared. Now, I don't actually care about this, but x minus 1 squared. I could have just left it as v squared. Why don't I care? Because what I'm actually wanting to do is set the top of this fraction equal to 0 to find the stationary points. Okay, expand the brackets. Outside 2x squared, first 2x squared, outside 3x, inside minus 2x, lasts minus 3, minus x squared minus 3x. All still over x minus 1 squared. 2x squared minus x squared is 1x squared. 3x, take 2x is 1x, take 3x is negative 2x. Negative 3, and that's all. Can I factorise the top? Yes, I can. I'm going to save myself a bit of writing by saying what I want to do. That equals 0 when the top of my fraction equals 0. X squared minus 2x minus 3. So I need two numbers that add to negative 2 and multiply to negative 3. So I'm looking at 3 and 1, and I must have negative 3 to get a negative sum. So that's x take 3, x plus 1. Therefore, x equals 3 or x equals negative 1. Those are my two stationary points. Let me have a look back at the graph again. 3 looks reasonable and negative 1 looks reasonable. That's good. Okay, can we work out what y is at those points? Let's substitute in. At x equals 3, y is 3 squared plus 3 times 3 over 3 minus 1, which is 9, that's 18 over 2, which is 9. And if x is negative 1, I have negative 1 all squared is the same as 1 squared, plus 3 times negative 1, oops, forgot my y equals, over negative 1 take 1. Well, that is 1 take 3 is negative 2 over negative 2, which is 1. Let's have another look at my graph. I should have had x equals 3, y equals 9, which is actually a little bit lower. I'll do that in a slightly different colour to show you. It should have come down to here, 3, 9. So I wasn't too far off. And it should have come up to -1, 1, which is here, is my maximum, -1, 1, which means the graph really went to a maximum there, then curved down again. So my original pink was pretty close to the correct curve. And this is why I say, for the sake of just a quick sketch, it doesn't necessarily matter if you find that exactly. But if you want to, differentiate, make it equal to 0, substitute back in, but be careful to do so into your original function, not the derivative.